In this lesson, we're on day 2 of our regular polygon lesson. This lesson is going to focus on all the other regular polygons. In the previous lesson, we talked about the regular triangles, regular quadrilaterals, and regular hexagons. So here we're going to look at all the rest of the possibilities. The rest of the possibilities kind of fall into one category where we're going to use the formula area equals 1/2 apothem times perimeter. So our goal is to find the apothem and perimeter of every situation that we come across. First thing I would do is I would draw out a generic bottom of a polygon like I did down here on the bottom of my page, just to help calculate the measures of the central angles and any side lengths that we have to use. So let's say here we have a pentagon. So if we have a pentagon, that means we have 5 sides. If we have 5 sides, to find our central angles, what we would do is we would take 360 degrees divided by 5, which puts us at 72 degrees each. So each central angle is going to be 72 degrees. Now remember that the apothem cuts the central angle in half, so half of 72 degrees is going to be 36 degrees. So this is just a general flow of how we're going to use that bottom half of the generic polygon to help us keep track of everything. So here's our first example. We got our perimeter that is 60 inches. We have an octagon. So being that we have an octagon with 60 inches, which makes 0 sense because what the hell? In our first example here, we have a regular octagon that has a perimeter of 56 inches. First thing we need to do is we need to know our central angle. So to find our central angle, we would take 360 divided by 8, which is 45 degrees. So if that's 45 degrees, what that means is that this top angle in our little right triangle that's created here with the apothem and the radius is half of 45. So half of 45 is 22.5. And a lot of students will freeze here because 22.5 isn't the kindest looking angle measure in the world, but it is what we want it to be. So we're going to stick with that 22.5 degrees in that angle of that triangle. So now with the 56-inch perimeter, we would take 56 inches divided by 8 to find out what each of the side lengths are. So 56 divided by 8 gives us a 7-inch side. So we know that that's 7 inches. We know that this is 3.5 inches because that's half of a side length. Now the piece that we're missing here and the piece that is critical for us finding the area is the apothem. The reason that's our critical piece is because our formula 1/2 apothem times perimeter, we know the perimeter, but we do not know the apothem yet. The perimeter is 56. So to find that apothem, what we need to do is we need to use a little bit of trigonometry. So being that our angle at the top here is not a 30, 60, or 45 degree angle, we're stuck using trigonometry. So we're going to think back to SOHCAHTOA. In SOHCAHTOA, we got sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. Because we're working from the central angle location, the apothem is the adjacent side, and the 3.5 is the opposite side. So that tells us we're looking at using a tangent function. So the tangent of our angle is equal to the opposite over the adjacent. So we have the tangent of 22.5 is equal to 3.5 over 8. We would exchange these two pieces diagonally because our variable is in the denominator of the fraction. That allows us to get our variable by itself on the left-hand side and gets our number and our trig function on the right-hand side. So we have 3.5 divided by the tangent of 22.5. This will allow us to find our apothem. So we're going to pull up our calculator here, pop that on. I can see up at the top here I'm in radians. So I want to make sure I go in and I change my mode to degrees. And now I'm going to go 3.5 divided by the tangent of 22.5. That gives me a 8.4497, so I'm going to go with the 8.45. We'll pop up here. We'll plug in that 8.45. We'll hop back to our calculator. We're going to go 1/2 times 8.45 times 56. And our area is 236.6. And that would be in square inches. In this example, what we have is we have a regular decagon. Keep in mind a decagon has 10 sides to it. And they're giving us that we have a radius of 8 inches. So we can go ahead and label our radius at 8. If we have 10 sides, that means our central angle, 360 divided by 10, is at 36 degrees. Half of 36 degrees, because the apothems will split our central angles in half, would put us at 18 degrees. And now we can go ahead and start figuring out what we need for our formula for the area, which is 1/2 the apothem times the perimeter. Unfortunately, in this case, we don't know either the apothem or the perimeter, so we're going to have to do a bit of work on this one. So we have our 18-degree angle. This is our hypotenuse, the 8. We're going to need our opposite side here and our adjacent side. That means we're going to have to use trig twice. So we're going to throw down SOHCAHTOA. Just for a reference of our trig functions. So to find x, our opposite side, what we're going to do is we need to use the hypotenuse and opposite, which means we're focusing on the sine function. So the sine of our angle is equal to the opposite over the hypotenuse. So the sine of 18 degrees is equal to x over 8. Our variable is in the numerator, so we can go ahead and multiply both sides by 8, giving us x equals 8 times the sine of 18. So we'll go ahead and pull our calculator up. We have 8 times cosine of 18 degrees, which is 2.47. Which is the equivalent of x. Now, we're going to have to double that 2.47 for each side length. And then multiply that answer by 10 to get our full perimeter. So what I'm going to do on my calculator here is I'm going to take that answer. We're going to double it to get our full side length. And then I'm going to multiply it by 10 because I have 10 sides to get our full perimeter. So as I look at my screen here, here's what x is. Here's what each side length is. And there's my perimeter. The perimeter is what I want for my formula, so I'm going to go with 49.44. Jumped around a little bit on me. So 49.44. Now we're going to shift gears here. We're going to have to find the apothem. The apothem is the other piece that we are missing. So the apothem is the adjacent side. We're always going to use the exact side that we are given to begin with, which is the hypotenuse. So adjacent and hypotenuse means we have to focus on our cosine function. So the cosine of an angle is adjacent over hypotenuse. So the cosine of 18 is a over 8. We can multiply both sides by 8. So our apothem is 8 times the cosine of 18. From this point, we're going to pull up our calculator. We'll clear off the other stuff. We got 8 times cosine of 18. That gives us a 7.61. So that's the length of our apothem. Pop up here, 7.61. Now we have enough information to run with. We can find our area. It's just a simple calculation with your calculator. We'll clear that out. Half times 7.61 times 49.44. That gives us an area of 188. Just need to catch the rest of that decimal. 0.12. Square inches. And that would be our answer for the area of this regular decagon with a radius of 8. For our final problem, we're going to be looking at a dodecagon. For those of you who forget, a dodecagon has 12 sides and an apothem is 6. So we have our apothem here is 6. We can do our 360 divided by 12, which is 30. Now we have to be careful on this because a lot of people get caught into the 30, 60, 90 concept here. But the trick is our 30-degree angle is our central angle, not the angle that's created with the apothem. The angle created with the apothem is half of the 30, which is a 15-degree angle. So it does not fall into the 30, 60, 90 category. For this problem right here, all we need to do is find the x, because if we look at our equation, 1/2 apothem times perimeter, our apothem is 6. We're good there. All we need is the perimeter. So if we find x, we can double it to get a full side length and then multiply that by 12 to get our perimeter, and that's all we need to finish off our equation. So let's work on that. Being that our angle is not a 30, 60, or 45 degree angle, we have to use trig. So looking at SOHCAHTOA and looking at our angle up here, we have our opposite side at x, and we have our adjacent side at 6. Opposite and adjacent dictates that we have to use the tangent function. So the tangent of our angle is equal to the opposite over the adjacent So the tangent of 15 is equal to x over 6. So with the x on the top, all we have to do is multiply both sides by 6. My pen didn't quite catch on there, so let's try it again. So 6 times the tangent of 15. Go ahead and calculate that on our handy dandy calculator here. 6 times tangent of 15 puts us at 1.607. Now, this is the x part of this. Remember back up here, we want the perimeter. So if I have x, I can double that to get the side length and then know that I have 12 sides to work with. I need to calculate my perimeter. So I'm going to take this answer here, I'm going to double it to get my side length. I'm going to multiply it by the number of sides to get my perimeter. All right, so as I look at this, here's my x value, there's my side value, and here's my perimeter. My perimeter is at 38.58. Now I can go ahead and calculate this out. Half times 6 times 38.58 gives us an answer of 115.74. And we're working in square inches, and that would be the area of my dodecagon with an apothem of 6 inches.